Now that we have seen the shift cipher and the affine cipher, let's talk a little bit about security. So one of the problems with these ciphers is that they have very small key spaces, right? So the key space is the set of all possible keys, right? So and of course, if someone guesses the key, an attacker can just solve the problem. He can break your scheme. So for the shift cipher, the key is just the shift amount. And so since we're working modulo 26, there are only 26 possible shifts. And that means that an attacker could just try all 26 possibilities. And so this is called a brute force attack, right? Trying all the possibilities. And it's not that many, right? Someone could solve it in a couple of, in less than a minute maybe. Now, the affine cipher has more keys, but still not too much, right? So now it's a pair, A and B. There are 26 choices for B, but A must satisfy, so it's not 26 choices for A because it needs to satisfy that it's co-prime of 26. And you can actually go and check that there are 12 such values for A that are co-prime with 26. And so the affine cipher now has 12 times 26 equal to 312 possible keys. So that's larger than 26, so it'll take a longer time to break, but it's still tiny from a security perspective, right? So shift and affine ciphers, they're essentially very easy to break by brute force. You could sit down and just by hand test out possibilities and you should be able to solve it and not take too much. So let's look at the substitution cipher. So this is a bit of a more general idea. And the idea is that instead of using like some formula like P plus K, right, or like adding a key or doing an affine combination, we choose any one-to-one replacement rule for the alphabet, right? So now the idea is that each plaintext letter is replaced by a ciphertext letter according to some fixed permutation. So you choose some permutation. So to every letter, you assign a different letter. And now the key is how do you assign, right? So now if A, you assign an X, B, you assign a Q, C, you assign an L, this rule here is actually going to be the secret key, right? Now, so in this example here, if you want to write like the message, like let's say you want to send hi, then an H is an E, and the I is a T, and so you send ET. And if the person knows this here, which is the whole key, they can decipher ET to be high, right? Because they go here ET and it's high. Okay. So now this gives a much larger key space. So there are 26 factorial ways of permuting the 26 letters, right? So how many ways can you permute 26 letters? 26 factorial. That's a huge number. It's approximately like of order 10 to the 26. So brute force is not a realistic attack for this, right? Not a realistic attack. But this still doesn't mean that this cipher is secure. And the reason for that is that the cipher still preserves patterns from language. And so one of the ways to attack that is through something called frequency analysis. So the main weakness of substitution ciphers is that they preserve the letter frequencies. So in English, some letters appear much more often than others. So for example, the letter E is usually the most common letter. And then you have letters like T, A, O, I, and N are also very common. And so in a substitution cipher, every plaintext E, for example, is going to be replaced by the same letter, right? Maybe E is replaced with the letter X. And so now every time you use the letter E, you're going to send an X. But now what happens is that whatever letter represents E, so let's say X, is going to appear with the frequency that you would expect an E to appear, so very much. And so this gives the attacker a clue on what to do. And so the attacker can count how often each ciphertext letter appears and compare those counts to typical English letter frequencies. And so this is called frequency analysis. And so, for example, if one ciphertext letter appears much more often than all the others, maybe it's the letter E. And then the attacker can refine the guess by looking at common words, repeated patterns, and context. So the substitution cipher has a huge key space, but it still leaks information because it preserves the statistical structure of the plaintext. And so this is an important lesson. Having many keys is not enough. A ciphertext also needs to hide patterns in the message.